Okay, here we go. Let's open this blind. I feel like it's dark in here. Too dark. Oh. Go. Okay, so trigonometry, what is it? We're going to be learning and determining side lengths and angle measures in right triangles using primary trigonometric ratios. So, back in grade 9, you guys did a lot of Pythagorean's theorem. That rings a bell, right? C squared equals A squared plus B squared using right angle triangles. So we are going to be learning new ways to be able to determine angles and side lengths when given right triangles as well as acute triangles. Then we are going to be able to solve problems like real-world application using trigonometry. And we are going to be learning new terms called sine law and cosine law, and it's these laws that we're going to be using to determine angles and side lengths of acute triangles. Okay, so we're going to be looking at right angle triangles and acute triangles, and we're going to be able to figure out using trigonometric ratios and sine and cosine law the different angles and side lengths of these triangles. Okay? So I will underline that. You can underline sine law, cosine law. Okay? So what is trig? Area of mathematics that studies the relationship between the angles and side lengths in a triangle. First half of the unit will be right triangles that we'll be looking at, and we will be using, like I said, the primary trigonometric ratios, which we call SOHCAHTOA. Have you guys heard that before? SOHCAHTOA? Kinda, some of you. Second half will be triangles that are not right angle triangles, so acute triangles, and that's when we'll be using sine and cosine law. Now, very important. I know at the beginning of the course, I told you that we need to have our scientific calculators, and most importantly for this unit here. So it's very important that we're understanding how to use our calculator, and if you're not, then by all means call me over and we'll do some practice questions together. As we go through this this lesson, please have your calculator out. Where's mine? Emma or Alex, did I leave my calculator over there when I was working with Alex on the board? Do you see an extra one over there? Yeah, thank you. No, you can have it if you need it right now. Okay, so you will need a scientific calculator that has buttons that say sine, cos, and tan. So everyone look for those right now. Can everyone see sine, cos, and tan on their calculator, scientific calculator? If you don't have it, you need to figure out something for the week. Maybe do the same thing that Meisim and Alex did where they went and asked the office. I don't know, they just seemed to get free calculators from the office. I don't know how that worked, but on mine here, if you have the same as me, sine is here, cos is here, and tan is here. Okay, these are buttons that we're going to be using for the entire week. Okay, and you'll need it for your exam as well. What else do I have here? If you have an actual calculator, it must be in degree mode. If it's not in degree mode, then it's going to give you the wrong answer. So if you find that it doesn't, so usually it says like D up at the top. Does anyone see that? If it doesn't say that, then just like reset your calculator and it should just be automatically set to degree mode. Okay? Okay, so things that you can underline. Right angle. SOHCAHTOA is going to be something that we use a lot. Does not contain a right angle, sine, and cosine law. Okay, and today is pretty straightforward. I hope you guys, in the end, agree with that. Okay, so our first lesson, 7.4, 7.5, primary trig ratios, solving right angle triangles. So we are not going to be getting into like sine and cosine law until probably Wednesday. So for the first 2 days, we're going to be just looking at right angle triangles. Okay, so starting with labeling the right angle triangle. The right angle must be labeled. You can't assume it's a right angle. How do we label the sides of a right triangle? So this is probably fairly straightforward to you because it's a little bit of review, because when you do Pythagorean's theorem, it is a right angle triangle. So hypotenuse is always the longest side opposite to the 90-degree angle. So if it is a right angle triangle, you will always see this here. This always represents the right angle triangle, and we know from Pythagorean's theorem that the hypotenuse is the longest side, and it's always across from, so I'm going to circle this right angle. Hypotenuse is always across from the right angle triangle. Opposite side to an acute angle is the side across from the angle. So in our next slide, we're going to have practice with this. But depending on what angle you're dealing with, the opposite and the adjacent side are going to change. So if you were looking at angle B here, you're going to have a different opposite and adjacent side than if you were looking at angle A. Okay, so we will see that in the next slide. So hypotenuse, use short form hype. There will be a different adjacent side for angle A than there will be for angle C. Okay, so that's exactly what I talked about, and we'll see this in the next slide. Okay, so you can just to show the differences, we have angle A, B, and C, and depending on what angle you were given or what angle you were asked to find, the two other sides, opposite and adjacent, are going to depend on that. That's all I wanted to say there. Okay, so let's actually do an example of that so that you guys can see and learn how to properly label the different sides of a right angle triangle. So let's label opposite and adjacent for angle B. So if you are looking at angle B, we're dealing with this guy right now. We're not dealing with C and we're not dealing with A. We're only looking at angle B. Well, we know that the right angle, the side opposite to the right angle is always going to be the hypotenuse. Okay, so that one's easy. No matter what, opposite to the right angle is your hype every single time. Because we are looking at angle B, so actually I'll still use blue. The side across from the angle that you're looking at is always the opposite side. So the side across from B is this guy here, and we always label that opposite. Just is what it is. Okay? Then the side next to the angle that we're dealing with is always the adjacent side. Okay, so here, right, next to is adjacent. Okay, so across from the right angle is always the hypotenuse. Depending on the angle we're dealing with, in this case it's B, so the side across from that angle is always opposite. The side next to that angle is always adjacent. So help me do this one now. So in this case, we are now going to look at angle A. So if this is angle A here, well, right away, if this is our right angle, then across from that is our hypotenuse. Right? When we come to the side across from angle A, that is the opposite side. And if we look to the side next to angle A, then that is the adjacent side. How do we feel about that? Does that make sense? Okay, every single time. If we're looking at angle B, well, across from it is going to be opposite, next to it is adjacent. If we look at angle A, well, across from it is going to be opposite, next to it is going to be adjacent. Hypotenuse is always across from the right angle. Questions about that? Yep. Alex? They are the exact same triangle. So we're going to get into it. So we're going to look at sine, cos, and tan. But in general, right now we're just looking at how to label a triangle. So we're going to get into, okay, well now we actually have a question that we have to solve. But before being able to do something like that, you have to be able to label a triangle. So if a question said something dealing with angle B, then you know that across from angle B is always the opposite side. Next to angle B is the adjacent side. You need to know these terms because we're going to see on the next slide that we're going to do a calculation with it. So right now, all you need to understand is how to label the triangle. So if the question is dealing with angle A, you just need to, so far you just need to know that the side opposite to it is called the opposite side. The side next to it is called the adjacent side. That's all we need to know so far. Okay? We could do another one, but it's just going to be the same thing. Okay? Same thing over here. If we were dealing with angle B, across from it is opposite, next to it is adjacent. Okay. So it says here, the relationship between the sides and angles can be described using the trigonometric ratios sine, cosine, and tangent. In grade 9, you use Pythagorean theorem to calculate side lengths. This is the next step with questions that may involve angles. Okay, so we're moving on. We were used to using Pythagorean's theorem. Now we're going to be using something called primary trigonometric ratios in order to be able to determine side lengths and angle measures. So it says here, we will use the symbol theta, the Greek letter, to represent any acute angle in the right angle triangle. So this little sign here, guys, represents theta. That theta is really representing the angle in a triangle. And we're going to do practice questions with this. Okay, so until we do a practice question, it's not going to make complete sense. Okay, but this theta here, that is always going to represent the angle that you're dealing with in the question. Okay? Okay, so we have 3 primary trigonometric ratios, sine, cosine, and tangent. So if you look down here, I'm going to use red is fine for this. So when we are using our sine calculation, so sine theta, and again, theta is going to represent the angle that we're dealing with in the question, we are always going to do the calculation of opposite divided by hypotenuse. So again, when we do the questions, it's going to make more sense, but this is one of the 3 primary trigonometric ratios that we're going to deal with. If you are using the sine button on your calculator, that's because you have opposite and hypotenuse. If you are using cosine, you are going to be using adjacent divided by hypotenuse. And if you are using tan, you are going to be doing opposite or op over adjacent. So we will use the acronym SOHCAHTOA to help us remember the ratios. So the reason I did this in different colors, and if you always remember SOHCAHTOA, then you're always going to remember which is which. So when you use sine, it's opposite over hypotenuse. So sine, S for sine, opposite over hypotenuse. If you're using cosine, adjacent over hypotenuse. Do you guys see how this is matching up? Okay, and then TOA is when we're using tan, and that's going to be opposite over adjacent. Okay, right now it's just showing you this, but we're going to do practice problems that actually deal with this. Okay, so we are learning 3 new primary trigonometric ratios to calculate side lengths or angle measures. And this is what we need to remember, SOHCAHTOA, because if you remember SOHCAHTOA, then you're going to remember what calculation to do. Okay? Is that all I wanted to say there? Yes. Okay, so this is just a little bit of straightforward practice. Use your calculator to evaluate the following. So I want everyone right now to type in sine. Here, I'll put this on so you can see better. So everyone should have a SIN button on their calculator. And then 50. Most calculators are going to put a bracket. So you're probably going to notice that it's going to come up like this. And you're going to put that in. You can close the bracket if you want to. You don't have to. Okay, so if you end up just pushing like enter like that, that's fine. You're going to get the exact same answer. Okay, so push sign and then just type in 50. Does everyone get 0.76604443? You get 50. Okay, so let's see. Okay, where's our sign button? Oh yeah, there we go. Sign. Why isn't it coming up? Well, that's not working properly. Let's reset just to see. Yeah, I don't know why that's not working. Yeah, go ahead. But when you go to do it, we're going to be rounding to 4 decimal places. So you can write the whole number and then we'll do the round together. No, this is right, degree form. So maybe your calculator just doesn't work properly. What are you? You're sharp. Okay, so after the lesson, maybe we can look this calculator up, but this should be, like, when you push sign, it should be coming up SIN. But it's not. Do you have the same one as this one? Yep. Okay, so if you have one that looks like this, like I said, I'm most familiar with the one that I have, but when you push sign, like, it should be coming up. And it's not, so we'll figure it out after the lesson. Okay? I don't know if the calculator has these buttons, then there has to be some sort of way, but every calculator is different, right? So if you have this calculator and it's not working, well, we'll have to figure it out after the lesson. Okay? Christian? Okay, so let's reset. Isn't all calculators supposed to have a reset button? Because it has to be in degree mode. Okay, so same thing. We'll have to look at it after. Did you get it? Oh, sorry, I thought you were... Oh, so yours is different. You click the number and then sign. Wonder if yours is the same. 50, sign. No. 50. Okay, we'll try to figure it out after, okay? It's weird that your calculator doesn't have a reset button. Okay, but otherwise, for the most part, we're okay with that? Okay, so, sign 50, you should have gotten that number, 0.766044443. When evaluating the sine, cos, or tan of a given angle, we will often round to 4 decimal places. So this is when your rounding skills of elementary school need to come into play. Okay, so in this case, 4 decimal places, 1, 2, 3, 4. Well, this is a 4 here. And when we have, remind me of the rounding rules. So 5 and higher, we round up. Lower than 5, we keep the same. So because this number to the right of the 4th decimal place is lower than 5, it's just going to keep the 0 the same. Okay, so let's do the next couple together. So if you were to type in sine 36, you should be getting 0.587785252. And now let's round that together. So if I want 4 decimal places, if I want it to stop here, then I need to look to the 8 to see what it does to the 7. So what's the 8 going to do to the 7? Round it up, so it's going to become 0.5878. Are we okay with that? Next one, sine 40. 0.642787,609. Did we all get that? We want to go to 4 decimal places. So my 4th decimal place here is a 7. sorry for you guys on that side, a 7 here. So I'm going to look to the next number, which is an 8. This is 5 or higher. So what's that going to do to the 7? It's going to turn it to an 8. We're good with that? Right now is just practicing putting sine, cos, and tan into your calculator and rounding to 4 decimal places. Okay. So let's do our first question. So far we've learned SOHCAHTOA, but you haven't learned how to actually apply this. So you're probably looking on that slide like, okay, I see SOHCAHTOA, I see that sine theta is opposite over hypotenuse, but I don't get how we're going to use that. Well, now we're going to do questions to show you how you're going to use that. Okay? So this question says, determine the value of x to 1 decimal place. So remember I said, we're using these primary trigonometric ratios to get either unknown side lengths or unknown angle measures. Well, in this case, we have an unknown side length. We want to figure out what is x. So right away it says here, step 1, label your triangle relative to the angle. So in this case, our angle is here. So we have 51 degrees here. So let me just highlight that for you. That's our angle. So it says determine the value of x. So if this is our angle here, I'm going to draw a line from the angle to the side opposite to it. So what is this, the label of this side? Opposite. Okay, are we okay with that? So if this is our angle of the question, we just learned on the last couple slides that in order to label our triangle correctly, the side opposite to the angle is our opposite side, OPP. Now, the side next to the angle, so next to is, wow, I'm struggling with writing next to today. Not putting the extra T in. What do we call that side? Adjacent. So I'll put right up here. Are we okay with labeling our triangle? Same thing every time. Opposite of the angle is opposite, next to the angle is adjacent, and we know, and we don't even have to label it because it doesn't matter here, because we don't care really about this side, because it's not part of figuring out x, but this side is opposite of the right angle, which is called the hypotenuse. Good. Okay, so the next thing, determine which trig ratio to use. So let's write it out. SOHCAHTOA. So in this case, what two sides are we dealing with? What are they called? What are the names of our sides? Opposite and adjacent. So which primary trigonometric ratio, sine, cosine, or tangent, are we going to be using for this question? If we have O and A. TOA, okay? So that's why it's important to be able to label your triangle, because if you label this incorrectly, then maybe you're going to use the wrong trig ratio. Okay? So because we have opposite and adjacent, O and A, we know TOA is O and A. Tan, sorry. So we are going to write, am I on blue? Tan theta. You can, actually I'm going to rewrite that. You can honestly just draw a circle with a line through it. So tan theta equals, well, we saw in the last slide, op over adjacent. Okay, and if you're wondering how could I come up with that, we'll just come back to here. Tan theta is op over adjacent. Okay? Tan. Remind me, I told you theta is always representing what? What is theta always representing? The angle. In this case, what's our angle? 51. So tan 51, we're going to sub 51 right in for our theta. Equals, what do we have for our opposite side? What's the only thing we know about our opposite side? X. What is my adjacent side? 30. Good. Now, this is where, like, review of, getting rid of fractions, elementary school grade 9 comes into play, and we'll review it. So in this case, we want to be able to figure out x, right? We're trying to figure out this unknown side length, the length of the opposite side. So we want to get x on its own. So in order to get rid of this 30 on the bottom, do you remember what we do? Multiply. So we are going to multiply this side by 30, and what you do to one side, you always have to do to the other side, right? So if we're multiplying this side by 30, so I'm just going to cross those out. Then we have to multiply this side by 30. Are we okay with that step? It just is what it is. That's math. So if we want to get x on its own to determine the value of x, well, we have a fraction here. So if we multiply this side by 30, it's going to get rid of the 30 because we have two of them. But if we multiply the right side by 30, we have to multiply our left side by 30. Okay? So I'm going to rewrite that line out. Are there any questions from this step to this step? So we've got rid of these guys. So that's really what we're left with on this next line here. Okay, so now this is something that you could just type into your calculator. So I want you all to type in 30 tan 51. And if you have the different calculator, figure out how that works. 30 tan 51. What do we get? You should be getting 37.0469. Okay, maybe your calculator forces you to put 30 in brackets. So if it didn't work for you, try putting 30 in brackets. 37, I'm going to write it on the board. Don't worry. 37.0469 you should be getting. Raise your hand if you're not getting that. Okay, so you guys have the weird calculators, right? So again, we're going to have to figure that out after. But everyone else with the other calculators got 37 point. Wonderful. Okay, so now listen, you could have done this two ways. You could have figured out what tan 51 is. So if you type in tan 51 right now, it's going to give you some sort of decimal. Someone do it. What does it give you? Okay, so now multiply it by 30. Maybe your calculator makes you do that step. There you go. Okay, there you go. So sometimes it might be preference. You don't have to. You could have just typed in 30 tan 50 and it should give you the right answer. But if it doesn't and you're struggling, get tan 51 first. Right? That's what we just did on this slide. That was the whole point of this side, to be able to practice with this. So if you do tan 51, it's going to give you a decimal and then multiply it by 30. Okay? So you should have gotten 37.0469 equals x. And then when we are getting the side lengths, you can round to one decimal place. So when we did angle measures, it was 4. So in this case, it becomes 37.0. Now, determine the value of x to one decimal place. And now, if the question gives you units, you need to make sure you include those. So what should the unit be here? What's the only unit they give you? Centimeters. Okay? Questions about that guy? So far, so good? That's right. So if this was a 5, you would have changed this guy to a 1. Good question. All right, here we go. Next one. Determine the value of x to one decimal place. So our very first step is label your triangle relative to the angle. So here's our angle. So help me. This side here is going to be labeled what? If this is our angle and this is the opposite side of the angle, what is this? Good. And if this is the side next to, what's it going to be called? Oh, sorry. No, that's wrong. Nope. That's my bad. Because this is the right angle, this is going to be good. See? Oh. Okay, so it's very important, even I there. Sometimes it's natural for us to do that, but right away, we see that this is the right angle, and any side across from the right angle is the hypotenuse, so this would have been the adjacent. Okay, so I'll just circle that, and we call that hyp. The next step there says, determine which trig ratio to use. So every time, we're going to say, so, ka, toa. Well, what two sides do we have? Op and hyp. So it's going to be, what's the trig ratio called? What's this guy? Sine. Sine. Sorry, I was looking at, I thought I didn't move this right properly like that. Okay, so, circle. Sine theta equals opposite over hypotenuse. Okay, now we're going to fill in what we have. So, sine, what's my angle? 42. Good. What's my opposite side? Good. What's my hyp? X. Good. Now, there are multiple ways to do this. So I'm going to show you all three ways, and you decide which way you like to do it. Okay? So, right away, if this is our x down here, and we want to get rid of the fraction, what do I multiply this side by? How do we get rid of this guy? We always want to get rid of the fraction. So think back. Down over here, we had 30 here, and we didn't like it, so we multiplied it by 30. So if we have x down here and we don't like it, what should we multiply this side by? X. Good. So if we multiply this side by x, we must multiply this side by x. Cross those guys out. Now, I'm just going to come this way. And it's similar to what I showed you on the last slide. You can put sine 42 into a decimal place if you like that better, because then it kind of, I feel like we're used to seeing numbers instead of something like this. So if you prefer that, then you can do that. So if you were to come over here and do it that way, you would have x, and then sine 42, everyone put that into their calculator for me and round to 4 decimal places. You should get 0.6691 equals 4.5. Are we okay with that? Remember over here, we got rid of our x's, so really it looks like that. But I went this way and I dealt with the sine 42 and I put it into a decimal place. You don't. I'm going to do the other way over there. Okay? So, now, in order to get x by itself, what do I need to do to this side? And don't let this confuse you. If I gave you this, and I said I want x by itself, what would you tell me to do? Divide by 2. And if I divide this side by 2, then I have to divide that side by 2. So if x is being multiplied by this number, well, how do I get x by itself? Divide it by what? Good job. And if I do it to this side, then I have to do it to this side. Crosses out. X equals, you would do 4.5 divided by 0.6691 into your calculator, and you should get 6.7 meters. 1 decimal place. 6.7 meters, because that's our unit. So if you like that better, or your calculator does better with turning into a decimal right away, that's fine. You can do it that way. If you don't care to do it that way, then we'll come over here. So we multiplied by x, got rid of them here, so really now we have x sine 42 equals 4.5. So I'm just going to rewrite that. Okay, in this case, we haven't turned that into a decimal, but it doesn't matter. We still want x on its own, so what are we going to divide this side by? And that's why I turned it into a decimal, because over here you guys were able to tell me, and I feel like this side is confusing you. But this here is still attached to the x, but I want x by itself, so what must I divide this side by? Sine 42. It's the same thing, just over here you happen to turn it into the decimal. So if I divide the left side by sine 42, what do I have to divide the right side by? Good. This cancels out. X equals, and you could type in your calculator 4.5 divided by sine 42, and it should give you the exact same answer. So again, it ultimately comes down to also like practicing with your calculator. What was it? 6.7. Let me just see this for a second. Okay, so I typed in 4.5 divided by sine 42, didn't even close the bracket, and it gave me 6.7. Okay, are we okay with that? Pretty good, right? Pretty straightforward. Now, there is a third way, but I don't think anyone's going to use it. I'm just going to say it to you. I'm not going to write it down, though. Another way that you could have done this is if you look here, we have x times sine 42 equals 4.5. Well, really, everything is always over 1. So this x times sine 42 is over 1. Okay? And then over here, we have 4.5 over x. So another way to do it is you can flip both fractions and then carry on that way, but I feel like that's a little bit more complicated, and I feel like that's the last way that we use. Do you want me to write it down? You like these first two ways are okay for you guys? Okay. Another way is like flip the fractions, and then, so it's a little bit more complicated. It would still work, but I feel like it would be the last way I would use. So, no, we're good. Okay, next. Now, we've been given angles, and we've had to find the unknown sides so far. Now, we're going to find the angle using ratios. So, determine the measure of theta to 1 decimal place. So, we haven't had this yet. We were given theta, we were given angles, and then gotten the length of the unknown side. Whereas now we want to be able to figure out theta to 1 decimal place. We want to figure out the angle measure. So we use something called the inverse. So I'm just going to write this down here. You guys get it down and then we'll practice with it. So, sine, the inverse is sine to the negative 1. Cos, the inverse is cos to the negative 1. Tan, inverse is tan to the negative 1. Actually, not going to have you write that yet. Inverse operation to get theta value. Okay, so I'm going to show you how to use it on your calculator in 1 sec. I'll flick the lights on. But in order to now get our theta, our angle measure, we're going to use something called the inverse operation, and your calculator has the ability to do this. So the inverse of sine is sine to the negative 1. The inverse of cos is cos to the negative 1. The inverse of tan is tan to the negative 1. If we do the inverse operation, that is going to give us the theta value. So if you look up here, determine the measure of theta to 1 decimal place. Inverse is the reverse of an original statement. So, in order to be able to get the theta value here, we have to take the inverse. So what I want you guys to do, so on your calculator where your sine, cos, and tan buttons are, if you look above it, do you guys see right above the button, not on the next button, just like on the on the inside here, it should say sine to the -1, cos to the -1, tan to the -1. Does everyone see that? Okay. Oh. You see right above? So not the next button above, but in between the next button and your sine, cos, and tan buttons, you should see that there. So what you're going to do is type shift, or some of it might be second. So you're going to type shift or second, and then just in this case, we have tan. So we're going to use tan, and you're going to see it come up as tan to the -1. So everyone see that? And then you're just going to type this number in, 0.3711. And you should all get 20.4 rounded. Okay, so again, Christian, we'll have to look at it after. Geo, I don't know if your calculator is still giving you problems. Okay, you try that, Alex, because I stole your calculator on that one. You should get 20.4. Okay, so I'll flip the lights off because now we at least know how to do it. So remember, it's shift or the second button and then your sine, cos, or tan button. And then you're going to type in the decimal in order to get the angle measure. Okay, so and that's the thing is that like every calculator is different. For the most part, they should be similar, but we'll figure out how your calculator does it. Yes, Alex? 20.4. Yes, it's rounded to 1 decimal place. Okay, so we're always going to round our angle measures to 1 decimal place. Okay, so for this one, you would have typed in shift or second tan. That would have given you the inverse of tan. Then in this case, they gave the question of 0.3711. You'd type that in, and that's going to change it into the angle measure. Okay, now everyone try the next one, B. So it says we want to get the theta value. So if we're getting theta, we have to take the inverse. So we're going to do the inverse of sine, and then we're going to type in our 0.3907. And you guys should be getting 22.998 and rounding it to 1 decimal place, which is 23.0. Right, 22.9 rounds to 23. Okay, so same thing. Don't let that confuse you. You're honestly going to type it in as a fraction. So some of you might like to use your fraction button. I don't know, it's preference. You would do 9.1, press your fraction button, then 17.4. But if you don't like to use the fraction button, you would be doing 9.1 divided by 17.4. So everyone try this one too. Same thing. It's just one extra step. Okay, so for cos theta here, guys, you see a fraction. Don't let that stress you out. Okay, it's the exact same as if you had a decimal or a whole number. You're going to type it in just as is, 9.4 divided by 17.4, or like I said, you could push your fraction button so it keeps it in the fraction. But either way, you should get 58.46 rounded. It's okay. Let's try it. Okay. So what do we have here? Shift, cos. And let's see. So let's try without the brackets. Maybe your calculator likes brackets. 9.1 divided by... Have you been able to... Have you been putting the number first like Vanessa? Like, does your calculator work by putting the number and then cos? Or is it cos and then the number? We've been doing it? Okay. So let's try this. No, it's okay. Let's put it in brackets. Point. Okay, so look, your calculator just likes brackets. So you're going to go shift, cos, just like you would have because it's the inverse of cos. And then you're going to go bracket, 9.1 divided by 17.4, bracket, to close it up, 58.5. Okay, you're welcome. Yep. So listen, some of your calculators might like brackets. So if it's not working, do inverse cos and then put a bracket, 9.1 divided by 17.4, bracket. There you go. Okay. Sorry? Okay, so let's try without brackets just so that you know. Yes, this first. So shift, cos, and then it gives you to the negative 1. And then go 9.1 divided by 17.4. Doesn't like it, wants brackets. Shift, cos, bracket, 9.1 divided by 17.4, 58.5. Okay? Are we okay with that? Does everyone got this? Has everyone figured it out? Okay, so if we want theta, we have to do the inverse operation. Okay, so if you look here, I want it to make sense, so sine theta. Well, we want theta, so what would we usually do? We would divide by sine, right? We want to get rid of sine, we want theta by itself. So if sine is attached to theta, just like if this was x, we would divide by sine. So when you divide by sine, that really takes the inverse. So that's why over here it goes to theta on its own, because we want to get rid of sine attached to it. And then when we do that, it becomes the inverse operation. So sine to the negative 1, and then your same fraction or number that was over here. Okay? Questions about this? Are we okay with getting theta? Yes? Okay. Wonderful. Is there anything else I wanted to say about that? I don't think so. Okay, so mathematically we're doing the inverse operation just like you would, okay, 2x equals 6. So I used this example earlier. How do you solve for x? You would divide by 2 on both sides. So let's just do that real quick. 2x equals 6. If I said I want x by itself, you guys would all know and tell me to divide by 2. If you do it to the left side, you have to do it to the right. So x would equal 3. The same thing is happening here, and this is what I just showed you on the last slide. If it says sine theta, well, we want to get theta on its own. So when we divide by sine, on the opposite side, it becomes the inverse operation. Okay? So, solve for theta, and sine theta equals 0.667. So, I'm just going to rewrite that here. Sine theta equals 0.667. Okay, so in order to get theta, we always have to do the inverse operation. So in order to get rid of sine attached to theta, because we want theta by itself, that's what we're solving for, then you are going to multiply the left side by the inverse operation. What you do to the left side, you have to do to the right side. This really crosses this out so that in the end we get theta. Okay, so this is just kind of me showing you like the background steps in order to get to the inverse operation. Okay, so we want theta. In order to get theta by itself, we have to multiply both sides by the inverse operation. When we do that to the left, that gets rid of our sine so that theta can be by itself. But now on our right, we have 0.667 times the inverse of sine. Now, it's natural for us to see that first, so I'm only just rearranging here. Just like on the last slide, this is more how we saw it. So all I've done was flip them around. You don't have to do that. But because on the last slide, we were seeing theta is the inverse of sine or whatever it might be, cos tan, and then the number, I've just swapped them for you. So, you guys do that for me. What's the inverse sine 0.667? So you're going to do your shift sine, which will give you your sine negative 1 on your screen, and you're going to multiply that by 0.667. What do we get? 41.8. Yeah? Are we good? Okay, and again, like, if you're getting error, put it in brackets. If you're not getting error, then you know your calculator probably doesn't care about brackets. Right? Every brand is slightly different. So you should have I'm going to write here just so you remember. Cancels out. That's an E. Theta equals 41.8 what? Theta is always representing what of the triangle? Sorry, Mason? I didn't hear you. The angle. So what's the measurement? What's the unit of an angle? 41.8 degrees. So if you're getting theta, you should always have your answer in degrees because when calculating theta, it's the angle. Is it already 5 after? Wow. Oh. Yeah, we probably need about 15 more minutes. Give me 1 sec. So we'll be done before break. Okay, sorry, just had to email Mrs. Tarantella. Alright, we're getting there. So, just a couple more practice. Calculate the measure of each angle. So, theta equals, if I'm writing theta equals here, really I've done the step of getting rid of this cos, which is really multiplying this side by cos to the -1 and this side by cos to the -1. That's exactly what we just did on the last slide. Nothing new there. So I'm going to rearrange this because we like to see it like this. Is this the same example as the last one? Yeah, it is. Can someone do that for me? Cos to the -1. So that becomes 48 point what? 1 decimal place for our angles, right? Wonderful. Degrees. Over here, same thing. What do we get? $33.7, everyone should have gotten. Let me know if you didn't get that. Good? Okay, so we've done examples where we have a triangle, we label it, and then we calculate the unknown length. Well, now we know how to do a question where we label it and we have to calculate an unknown angle. So that's what we're going to do now. Right, so 2 different types of questions. Okay, determine the value of theta to 1 decimal place. So before it would say value of x, because that when we were trying to determine earlier, it was side length. Well, now it's theta, which is our angle measure. So, what does it say? Label your triangle relative to the angle. So, come on, blue. That's fine. So in this case, we have theta here because this is what we're trying to determine. We don't know the value of the angle. So if I was to come down here, opposite of the angle is opposite. Now, we have a right angle here, so opposite the right angle is called the hypotenuse. Say it was a value here, well, that's how you would know, well, this is the hypotenuse, so this would have been adjacent. But in this case, we don't care about adjacent. Toa, step number 2, determine which trig ratio. Well, we're dealing with hyp and op, which is going to be which trig ratio? Sine, good. sine theta equals opposite over hype. Fill in what we have. Sine theta. Well, we're trying to figure out theta, and we don't know what theta is. So that's our last questions. We were used to putting in the value there because we were given this. Well, not now. What's my op value? Good. 5 over 13. And now this is just like we were just doing. So now we want to figure out what theta is. So two ways. Putting it into a decimal or not. So sine theta equals, you could put 5 over 13 into a decimal. So if we do it that way, if you calculated 5 divided by 13 in your calculator, you would get 0.3846. But in order to get theta, what do we have to do? What type of operation? Sorry? Which we call the inverse operation. Right? So this is exactly what we just did over here. Okay? Look at cos theta equals. Well, now we have sine theta equals sine to the negative 1. Inverse operation. Can someone do that for me? What's the sine inverse of 0.3841? Or 3.46, sorry. Sorry? Wonderful. Or you could leave it in fraction form. It doesn't matter. Whatever you prefer, you're going to get the exact same answer. You could have typed in shift or second, sine, and then 5 divided by 13 and got 22.6, or you could have put the 5 divided by 13 into a decimal and then did your shift or second, sine, and then the decimal. Questions? Pretty straightforward? Wonderful. Next, determine the value of theta to 1 decimal place. So for this guy, we have theta here. Sorry, I should have used my, like I've been doing, highlighter on the last page. Here is our angle. So opposite the angle is going to be here, but we don't have a value, so we don't care about it. Our right angle is here. So if this is our right angle, then this is the hype. Next to the angle is adjacent. Okay, do you see how that works? Like we didn't, yes, this is the opposite, but there's nothing there, so it's not one of our values that we have. We do have opposite the right angle, which is hype, and we do have next to theta, which is adjacent. Step number 2, figure out what trig ratio. So if we have adjacent and hype, which ratio is it? Cos, good. So cos theta equals adjacent over hype. Cos theta equals, what's my adjacent value? Good. And I'm not going to do both ways here. You can, if you want, you can either go this way and put 5 over 11 to a decimal, or you can just go theta equals inverse of cos 5 over 11, and then you guys tell me what you get. Okay, so just like the last question, guys, you could have put this into a decimal first. If you want to do cos, inverse of cos, and then a decimal number, you can, or you can just type 5 divided by 11. What'd you get, Alex? Oh, sorry. No, yep, go ahead. We will have word problem questions. So it pretty much goes, our week pretty much goes, learn trig ratios, so Katoa, and then the next lesson is using this to solve problems. It's really not that, it's not too bad. Then we learn using non-right angle triangles, so like acute triangles, cosine law and sine law, and then word problems. So it just might be the word problems that might be a little bit more difficult, but we'll do a whole lesson on it. Yeah, Gio? Did someone get something else? No, it's okay. Try it again because your calculator is different, right? So I got 62.964, and then it says round to 1 decimal place. So I'm going to do that here. 4 degrees. So 63 and 1 decimal place would be what? Point what? Yeah. Gio, let me know if you type it in again if you get 63. Yeah, Alex? Yep, but you're going to miss 2 slides, so make sure you get them when you come back. Did you get it, Gio? Vanessa? Oh, you got it? You sure? And again, maybe like those of you with the weird calculators, maybe it's better to put 5 over 11 into a decimal. You guys would know best with your calculator. Okay. Oh, and it worked? Okay, perfect. I find that that's the case. Sometimes you have to put in brackets. Okay, next. 2 more slides. Determine the value of theta to 1 decimal place. Okay, so label your triangle relative to the angle. So if this is our angle, this side over here is labeled opposite. Good. Now we know that opposite the right angle is hype. So next to is, are we all good with that, guys? Labeling our triangle? Number 2, figure out which trig ratio you're going to use. Well, we have opposite and adjacent, so which one is that? TOA, good, tan. Tan theta equals opposite over adjacent. Tan theta equals, what's my op value? What's my adjacent value? Theta equals the inverse operation of tan. And then type in 6.8 divided by 4.5. I'm doing an extra step here because last time I didn't. So for those of you who like to put in decimal first, 6.8 divided by 4.5 is 1.5111. And if you were to then type into your calculator, what do we get? And we want 1 decimal place, so 56.54 stays at 56 point. Good. Questions? Did everyone get 56.5? Wonderful. Cold in here? I know when I came in, I find that like it's not until there's movement in the room that it starts getting warmer and like the heat starts kicking on, but when I came in at 8, it was freezing in here. Oh, on break. You gotta get moving. Alright, are we good here? Last question. Slightly different type of question that you might see, but after this slide you'll know how to do. One last example. Sketch triangle ABC in which angle B is 90 degrees and cos A is 5 over 9. So, right away, I'm going to draw a right triangle. Yours is probably going to look better than mine. Right away, you know it's a right triangle, right? Because we're only dealing with right triangles so far, and it also says angle B is 90 degrees. So, if this is my right triangle, which right here, here, or here is my 90 degrees? Here? Here? Yes. So this is going to be labeled A, B, or C? B, because it tells you that B is 90 degrees. So you could label this A and this C, or you might not necessarily have done that. This is B. You could have labeled this A and this C. It doesn't matter. Now, this is where figuring out where your values go comes into play. If it says cos A is 5/9, so let's write that. Cos of angle A equals 5/9. Well, if it's cos, if we're using cos, and A is here, right, because they're talking about angle A. We usually see like cos theta here, right, or cos 51. But in this case, it says A because that's the angle we're dealing with here. Well, if it's close and we have 5/9, well, tell me, this 5 and 9, what sides are they? How do we figure that out? If it's cos. So, ka, toa. If it's cosine, then what must be 5? Adjacent, and what must be 9? Are you guys seeing that? If it's telling us that it's cos, then right away, well, you know your primary trig ratios. If we're dealing with cos A, and we have 5 divided by 9, well, the top number is our adjacent side, and our bottom number is our height side. All it's asking us is to label the diagram. It's not asking us to do a calculation. Okay? So if we know that 5 is the adjacent side, and 9 is the height, then we're going to label, if we're talking about angle A, cos A, adjacent is here, next to, right? Are we okay with that? So 5. And height is across from the right angle. So this is 9. And then is there units here? No, there isn't, so it doesn't matter. Does that make sense, how we labeled this? So I know there's a couple steps there, but first, draw your triangle, then say, okay, well, it's cos, and we're dealing with A. That's very important. If this said B, it'd be different, right? Because we'd be looking at angle B, and then doing our labeling. Yep, it just wants you to be able to label the triangle. So let's just do it over here. If you guys had labeled A here instead of here, then if this is angle A, then next to is adjacent, which is 5. And across from the right angle is the hypotenuse, so that's 9. Okay, so do you notice how if A is over here, the side is different, like 5 down here and 5 over here. Okay, both are correct. It just all depends on how you labeled your triangle. Okay, so adjacent is next to, hype is opposite right angle. Are we okay with this one? Questions with this? No? Okay. So, in 2 seconds, you're going to go for break. I'm going for prep. So, when I'm gone, you have all of this to work on. And then here I say, if asked to solve, that means just find all unknown sides. So, go back to your note. Our first half of the note was being able to determine unknown side lengths. Then we learned how to get theta, which is the inverse operation. Okay, how do we feel about this first lesson of trig? It's okay? Okay, good. No, that's it. Okay, this was it. So after lunch, we'll focus on our word problems. I guess I could call it an in-class assignment now, because I'm allowing you to use your notes. And then whatever time we have left over will be more time for this. So hopefully you don't even have homework tonight. Hopefully you had enough time in class to be able to get it all done. Okay? Yep. Let me look it up for you. Okay? Okay, so that's it. So that's what you guys are going to do until lunch. Are we good? Okay, go for a break. Good job, guys. Really good job. Okay, Gio, just give me 1 sec because I need to turn this off so it's not in the video.